NASA's Artemis II mission, a pivotal step in the agency's ambitious program to return humans to the Moon, is now officially targeting September 2025 for its launch. This crewed lunar flyby will send 4 astronauts: Commander Reid Wiseman, pilot Victor Glover, mission specialist Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen, on an approximately 10-day journey around the Moon. The mission's primary objective is to rigorously test the Orion spacecraft's life support systems, environmental controls, and operational capabilities with a human crew on board, validating the entire Space Launch System (SLS) and Orion stack for human spaceflight beyond low Earth orbit. Unlike its uncrewed predecessor, Artemis I, this mission will not land on the lunar surface, but will perform a precise lunar flyby, pushing the boundaries of human endurance and technology further than any previous lunar mission. The diverse crew, representing the first woman, first person of color, and first non-American on a lunar mission, will conduct various critical tests and maneuvers, including manual piloting of Orion, communications checks, radiation monitoring, and demonstrating emergency procedures, to ensure all systems are robust and ready for the subsequent Artemis III lunar landing. The launch will originate from the historic Launch Complex 39B at Kennedy Space Center in Florida, the same pad used for Apollo missions. This mission is designed to demonstrate the full end-to-end capability of the Orion capsule with humans inside, from launch to splashdown in the Pacific Ocean, before attempting a lunar landing. The crew will also evaluate the habitability of the Orion capsule for extended periods, a crucial factor for future long-duration deep space missions. The defining capability of Artemis II lies in its human payload and the unprecedented distance it will cover with a crew, marking a significant leap in human deep space exploration. This mission will be the first time humans have ventured beyond low Earth orbit since Apollo 17 in 1972, bridging a 53-year gap in direct human lunar experience. The Orion spacecraft, propelled by the powerful Space Launch System, is designed to carry its 4-person crew approximately 6,400 miles beyond the far side of the Moon. This trajectory will take them further from Earth than any human has ever traveled, surpassing the maximum distance achieved by the Apollo program's record of 248,655 miles from Earth. The mission duration is planned for around 10 days, during which the crew will execute critical maneuvers, including a lunar flyby and a free return trajectory back to Earth, relying on the Moon's gravity to slingshot them home. The SLS rocket, standing 322 feet tall in its Block 1 configuration, is the most powerful rocket NASA has ever built, generating 8.8 million pounds of thrust at liftoff. This immense power is essential for propelling the heavy Orion capsule and its European service module on a translunar injection burn, a maneuver that requires escaping Earth's gravitational pull and setting a precise course for the Moon. The crew will also perform proximity operations with the Interim Cryogenic Propulsion Stage, ICPS, upper stage, ensuring the Orion's navigation and control systems are fully functional for rendezvous and docking scenarios, which are vital for future Gateway Station operations. The mission will also test the Orion's communication systems at extreme distances, a critical aspect for future Mars missions. While Artemis II is the ultimate real-world test for human-rated lunar systems, its foundation rests on the successful, uncrewed Artemis I mission, which provided crucial validation data. Launched in November 2022, Artemis I rigorously tested the Space Launch System rocket and the Orion spacecraft's performance in deep space, including its critical heat shield's integrity during a high-speed atmospheric re-entry at nearly 25,000 miles per hour, generating temperatures up to 5,000 degrees Fahrenheit. The mission covered 1.4 million miles over 25 days, demonstrating the SLS's ability to deliver Orion to the Moon and back, and proving the capsule's resilience in the harsh environment of deep space, including exposure to radiation levels far beyond Earth's protective magnetosphere. Data from Artemis I, encompassing thousands of sensor readings on propulsion system performance, thermal management, structural loads, and avionics, has been meticulously analyzed by NASA engineers. This extensive dataset serves as the primary, independent verification for the hardware's readiness, confirming that the core systems can withstand the rigors of a lunar mission. However, the critical element of human interaction with these complex systems, particularly the life support, environmental controls, waste management, and emergency procedures, remains to be fully tested with a crew on board. Artemis II will provide this essential human-in-the-loop data, validating the crew interfaces, operational protocols, and human factors that cannot be simulated entirely by uncrewed flights or ground tests, thereby de-risking future crewed missions. In the evolving landscape of crewed lunar exploration, NASA's Artemis program currently operates without a direct government-funded competitor with similar near-term objectives for a crewed lunar flyby. Historically, the Apollo program set the precedent for lunar landings, but Artemis II's mission specifically aims to test systems for future landings, not to land itself, making direct comparison challenging. The closest alternative or future competitor comes from the commercial sector, primarily SpaceX's Starship. While Starship is still in its early flight test phases and has yet to achieve orbital reliability or human rating, it is being developed with the long-term goal of lunar and Martian missions, including serving as the human landing system for Artemis III. Starship's design philosophy, emphasizing full reusability and massive payload capacity, presents a stark contrast to the expendable SLS, potentially offering a different cost and capability profile for future deep space transport. Internationally, China also has ambitious plans for crewed lunar missions, potentially by the early 2030s, and has made significant strides with its robotic lunar exploration, including sample returns. However, their current capabilities are not yet at the stage of a crewed lunar flyby, positioning Artemis II as a unique, near-term step in human deep space exploration, leveraging a traditional, government-led approach with international partners like the Canadian Space Agency. This mission also stands apart from private space tourism ventures, as its primary goal is scientific and technological validation for sustained lunar presence. Despite the profound technical achievements and historical significance, the Artemis II mission, and the broader Artemis program, face significant trade-offs and unresolved questions, primarily concerning schedule adherence, escalating costs, and long-term sustainability. The mission's launch date has already shifted from its initial 2024 target to September 2025, largely due to technical challenges in developing and integrating critical components, particularly the Orion spacecraft's life support systems, electrical power distribution, and environmental control systems. These delays contribute to escalating program costs, which have been a persistent point of contention. The Government Accountability Office, GAO, has repeatedly highlighted budget overruns and schedule slips across the Artemis program, noting that the SLS and Orion have cost tens of billions more than initially projected, with the per-launch cost of SLS estimated at over $2 billion. Furthermore, the long-term sustainability of the expendable Space Launch System, with its high operational expenses, remains a significant concern compared to the potential cost efficiencies offered by reusable commercial launch systems like Starship, which aims for a much lower per-launch cost. The safety of the crew on the first human flight of the SLS and Orion system is paramount, and any unforeseen issues during Artemis II could further impact the ambitious timeline for Artemis III and beyond, raising fundamental questions about the cadence and affordability of NASA's lunar return strategy and its ability to maintain public and political support over decades.